Hi everyone, thank you for coming to this session. My name is Leonard. I'm based out of the UK. I'm one of the technical support team leads. I work in the support team. A little bit about myself. I've been with Scale for over 10 years. Previous to Scale, I was a customer. So had the opportunity to join Scale, started in sales as a solution architect, and then moved into support where I am now. I look after the EMEA team, so we get a lot of support calls from EMEA, rest of the world. If you ever call in very early in the morning, then likelihood is you're speaking to one of my team. Today we're going to be running through some sort of hints and tips, things that we see from our customers, giving you some pointers, different aspects of the Scale cluster, and then we're also going to be doing a live Q&A. So get your phones ready to scan the QR code, which we'll be bringing up shortly. Get your questions posted in. I'm joined here by my two colleagues, Pat and Jim. Jim, want to introduce yourself?
Absolutely. My name's Jim Chamberlain, and I am also a support team lead. I have been with Scale for about almost 3.5 years. My path to Scale is vastly different than almost everyone else's. Prior to coming to Scale and working in IT, I was a pastor for 30 years, so I clearly give off youth pastor vibes. It's okay, it's a thing. But I love investing in our team and have just really enjoyed our time as we've prepared for this session and our time together this week. Pat?
Oh, yeah, sure. Thanks, Jim. Len, I can drive the next couple slides too if you want to sit down. Hi, everybody. My name's Pat. I'm based in Indianapolis, Indiana, with the majority of our support team. My Scale computing story starts in 2023. I'm the baby of this group. I started as a technical support tier 1, really quickly learned the ropes, the Hypercore OS, and then the vision and the goals of Scale computing and its support team. So now I'm happy to be here as a team lead for our 2 p.m. to 10 p.m. Eastern shift. So I primarily am in contact with you if you are an East Coaster having a very long day, or a West Coaster or Pacific rest of world region. So I wanted to get into our presentation, talk about the roadmap, what we're going to be talking about today. But first, I want to explain who exactly is Scale Care Support. If you have one takeaway from this presentation today, you should know there are 43 of us, and we're across 5 different time zones, and we are here to help you succeed. So there are multiple different ways to contact us. What are those ways? Well, obviously, many of you contact us via email. Writing an email to support@scalecomputing.com gets us in touch with you. Via the customer or partner portal is another way. If you have a community account, you can sign in and create a case or open a live chat with us to speak to some of us directly. And then the last way is obviously via phone. We have local numbers available at the URL there on that slide. Jim, I think you wanted to mention the appropriate ways to contact us depending on severity.
Yeah, I mean, really depending on how urgent your need is, we always want to stress, call us, call us, call us. It is the quickest way to get you connected directly with one of our software engineers, one of our team, and our support engineers, and we're going to get you the help immediately that way. We kind of like to think of it this way. If your house were on fire, you would not email the fire department, right? Call us.
True, yeah. And then the other thing that I will emphasize is that our support team has been at Platform. We've been at the Innovation Lab, and we'll continue to be at the Innovation Lab this afternoon, going into the evening. If you are a Scale computing support engineer in the audience right now, could you do me a favor and stand up, please? Could we give these folks a round of applause? Yeah. Awesome. Thank you very much. And those are the folks who day in and day out are doing the work, right? The 3 of us, we're just mascots. We're just up here giving presentations. Let's go ahead and talk about what we'll be discussing today. In part 1, we will give you a call to action. I'll put a QR code on the screen now. Use your phone to scan that QR code. That is an opportunity to ask any of our support team leads anything at all. We have some moderators in the front row. Wave Chris, wave Sarah. They are going to be receiving your questions and then sending them to us in part 3 of our presentation. We will do our best to answer as many of those as we can, as fast as we can, 10 to 20 seconds for each one. Part 2 of our presentation, you should consider it as support FAQs. So in the vast majority of our support casework, we get a lot of questions about three big topics. The first one, storage. How do I handle my cluster's storage? The second one, managing virtual machines in general. So RAM allocation, VM affinity to specific nodes or not to specific nodes. And then the third question that we deal a lot with is about snapshots and replication, the best way to manage them, the best way to handle them, cadences, that kind of stuff. So I'll leave this code here for a few more seconds and then we'll go ahead and get started. All right, everybody good? Cool. All right, we'll move on. Frequently asked question number 1, how do I handle my cluster's storage? I have the pleasure today of being up here to introduce you to your cluster's storage tab. In the HyperCore UI, at the very top, as this animation is showing, there is a disk utilization gauge. It's a little bar that fills up. It says 50% or 60% or something like that. If you click on that utilization gauge, you will find a storage tab. That tab is allocated in 3 different sections. We'll talk about what those sections look like. But first, I want to give a couple of disclaimers. That second bullet point there, 66%. We get a lot of questions from customers and partners asking, why do I have this condition on my cluster? That condition, 66% of your storage being utilized, is really just math. In a 3-node cluster, 2 nodes out of 3 would be 66%, right? The reason that we establish a little alert threshold there at 66% is because in the event that you were to lose a node, knock on wood, throw salt, your choice of superstition, your cluster would then have to reprotect that data. So 66% of your utilization, suddenly you're down a node. That gets tight really quickly. That's why the condition's there. The other condition that you should know about is 90%. 90%, usually the cluster is giving you ample alerts and warning that we were approaching that amount of utilization. 90% is a critical threshold. At that point, you're risking things like VM suspension, snapshot failure, cluster level IO issues. So usually our recommendation is never let it get to that point. But let's get into that whole storage tab that I was mentioning. The first section of that tab is called utilization. Utilization is the actual physical amount of storage that's being consumed across the cluster. So that's regardless of whatever you've provisioned to your virtual machines. It's whatever's truly being consumed right now. It includes all of your VM data, all your snapshots, all your replication cards. Replication is received and it fills up the cluster. And then there's a little bit of system overhead in that figure as well. This number is basically the most basic view of data utilization on the cluster, how full the cluster really is. This is the one that drives all of the alerts and the conditions we just talked about. The second section of your storage tab is the efficiency graph. Efficiency is basically how smart your cluster is at storing the data that you physically allocate to it. Thanks to compression and deduplication, the cluster will store more than it physically consumes. That ratio of how much more is being stored at the logical level versus the physical level is usually expressed there in that section as a ratio of 50%, 60%, something like that. I'll give you an example. If you had 2 terabytes of physical data being used, but you had provisioned up to 4 terabytes of VM storage for your various virtual disks, that would be a ratio of 50%, and that would display there in that graph. And then the last section of the storage tab is provisioned. This is basically what have you promised in terms of storage to all of your virtual machines. Many of us as sysadmins will say, I need a C drive that is this large, a D drive that is this large, an E drive, and so on. And thanks to thin provisioning, the cluster does not fill that instantaneously. Instead, it will gradually fill what you have allocated as blocks are claimed. The issue that support will often encounter is a lot of sysadmins will make it rain at a proverbial level, right? They'll say, I need 2 terabytes here, 4 terabytes here, 6 terabytes here, and then go, that's more than 100% of my storage. Oh my goodness, this is inflating quickly. And that's when we usually get involved. What I would caution everybody here to do is to basically take heed of all three sections of this storage tab: the utilization, the provisioned, and the efficiency, to get like a complete picture of what your storage looks like now, what expansion you need to plan for in the future, and then ways that you could potentially make that better. Thanks a lot for letting me talk about that. I'm going to kick it over to Len to talk about virtual machine management. Len, you want to come up?
Thanks, Pat. It's really interesting to see that because I think that's an area that a lot of people don't understand the storage tab. Some people in support. So it's good to have a good explanation.
Mm-hmm.
Okay, going to be talking about virtual machine management. Two subjects here: ensuring there's enough RAM available, and this is something that we see with customers that have maybe been with us a while, that are running a decent sort of setup, and then also VM affinity, how you can control where VMs start and what happens if something goes wrong. So let me just show you a picture of my cluster. This is my cluster at home, and I've highlighted it there. Got some VMs running on there, got about 40 gig of RAM available on each node. What I'm going to do is spin up a very big VM. This big VM is going to be 43 gig of RAM. The only node that's available for that to run on is actually node 1. So when I go to power on the node, there it is, it's powered up. Now we've got this alert pop up, which is telling us that there's insufficient free memory. Why is that? Why has that suddenly happened? Well, that's because the cluster is always checking to see what would happen if something was to go wrong. And in this case, it's saying, hey, if node 1 was to fail, that big VM, there's nowhere for it to move to. Now, we could just look to, adjust the memory for that and bring it down. And in the case of a failover, you can see these two small VMs would move across to nodes 1 and 2 okay. But the big VM, that can't move anywhere because there's no room for that to move on to the other nodes. So what could we do to fix this? Well, reduce the RAM maybe, or actually, we just move a VM from node 2 onto node 3. We're actually given enough RAM now for that big VM migrate across. So in this case, we've just sort of optimized how our VMs are positioned. And so now, if node 1 was to fail, the small VMs can still move across to node 2 or 3, but that big VM now has the ability to move across to node 2. Now, the cluster generally will take care of this automatically. It only tends to happen when you create VMs with very large amounts of memory. It tends to be what we see sort of customers being with us a while, that they're sort of building out a new VM. The takeaway is that when you're planning for this type of thing, we have to have at least one node with enough free memory on there for the largest VM to move to, should anything happen to the node that it's running on. Also, if a node does fail, we don't do any auto optimization of VMs, optimizing where they will be placed. Shouldn't be a problem because generally in the scenario I showed you there, that happens pretty much as you power on the VM. So you would know to take action and not just leave it and wait for the node to maybe fail. And the simple tip, maybe just moving one VM is all you need to do to solve that. So nice little tip there for managing VMs, large amounts of RAM. Next thing I'm going to look at is VM affinity, how you can manage your VMs in terms of how they start up, how down on nodes, and so on. We have three types of VM affinity. So we have VM node affinity, the one that you generally sort of see every day if you're just powering on a VM and live migrating it around. VM to VM affinity, and VM anti. The VM to node affinity, how do we set that up and what's it for? Well, very simply, all you need to do is live migrate your VM to your desired node, and that VM, then that node becomes the VM's home node, if you like. The node that it's come from is the backup. So we have a VM running on node 1, you live migrate it to node 3, then it will always start up on node 3. If we shut it down and power it on, it'll start up on node 3. But during an update, or if node 3 was to fail across to node 1. So that's the one we do every day. Very easy to do. You really don't need to do that one. The second one is VM to VM affinity. This is where you may want to have two VMs always running together on the same node. The application database server maybe that need to run together. So the way that we do this is migrate both VMs to say node 2, and then migrate both VMs back to node 1. So by migrating them to node 2, that becomes their home server. But when we then move them to node 1 becomes their home server, and node 2 becomes their backup server. So in the event that node 1 was to fail, we would both move to node 2. And during any updates that we do as well, when we do roll-in updates, the VMs will live migrate that particular order as well. So great use there. The final setup is VM to VM anti-affinity. One is a little bit difficult to understand, but I think you'll get it when I explain it. So what we need to do here is we have two VMs and we migrate them both to the same node, in this case node 3. Then we move one VM to node 1 and the second VM to node 2. So now the VM on node 1, that node 1 is the home node, the backup is node 3, the VM that's on node 2, that's its home node, but the backup is node 3. So in the event of a node failure, if node 1 fails, VM 1 powers up on node 3, VM 2 stays running on node 2. Never on the same node. When node 1 comes back online, the VM will be back. Likewise, if node 2 was to fail, that would move to node 3. When node 2 comes back online, it moves back. So the two VMs would never run on the same node. They'd be running standard on nodes 1 and 2, but never on the same node. So a couple of useful tips there. I hope you found that useful. But I think the one for me that's really useful is Jim's going to be talking about snapshots and replication. So Jim, do you want to come up?
Yeah, absolutely. Thank you. And that whole VM affinity kind of felt like a who's on first situation. But since that's a baseball joke, I probably won't make it since Len's British and probably wouldn't get it. But just kidding. Just kidding. I kid because I love. I want to talk about snapshots and replication. And this is my favorite feature because I like the fact that we have built-in security with our backups and the way that we do our snapshotting, so on and so forth. So the snapshots within the HyperCore are lightweight, point-in-time copies of a VM's full state. They're quick to create and can be taken while the VM is in production. No downtime, no extra load on your system. And it means that that snapshot can take place right in the middle of your day, right when things are busy. They're used for several purposes. Local rollback, for cloning, for replication. The local rollback, let's talk about that for a second. What happens when a patch goes wrong? Because that never happens, right? When a patch goes wrong, we can go back to a previous point in time and restore that snapshot and get our VM back and running. Cloning, you need a copy of a VM, a particular VM, and you don't want to build something new. You can just clone from the snapshot, boom, it's running very quickly. And then replication. The platform uses snapshots to replicate changes to the remote site. Our snapshots are crash consistent by default, meaning that the file system is intact while not preserving the memory state. But if you install our Scale Guest tools, if you do that, you can also take application consistent snapshots, which will ensure that things like your SQL server, your Active Directory, that those are flushed cleanly. And here's a real big plus in the whole thing. There are no parent-child snapshot chains to worry about. You can delete any snapshot at any time. You're not going to run into any kind of merge issue, no rollback tree, no drama, no weeping or gnashing of teeth to keep things biblical, I guess. So we want to get in the habit of taking our snapshots before updates, before changes, before chaos ensues. Oh, got to go to the next slide. Now let's talk about replication. This is your offsite insurance policy. Replication in the HyperCore uses or works by using snapshots to send VM delta changes to the remote cluster. That means that only differentials are sent, not great big full copies, just the differential from the last time that a snapshot was taken and replicated. That means that you can keep things rolling efficiently even over modest bandwidth, and that's a huge plus. and it enables true disaster recovery. Your primary production goes down, you've got a near real-time copy over on your disaster recovery service that can be restored at the remote site. The default schedule takes a snapshot about every 15 minutes. You can keep those short-term on your cluster locally, but then you can also change your retention policy so that you can keep snapshots for as long as you want over on your remote site. One thing we would say is you do want to manage those, but when disaster strikes, you don't have to fail over live. Instead, you can clone and restore directly there on your DR cluster the replicated VM and that has come from the target. You can boot it up and you're back in business. So whether it's ransomware, hardware failure, an act of God, whatever it is, replication means that your business doesn't have to stop when things go wrong. So let's finish with a quick recap here. The most important points about snapshots and replication are this: take them. It's built in, it's free. You're not paying extra for something that is built in and works and is so clean. Secondly, replication uses snapshots. If you're replicating VMs to another site, that replication is powered by our snapshot process. If you're not taking snapshots, you're not protecting to your remote site. So you want to make sure that they're scheduled, that they're healthy, and that they're happening as planned. And then the last thing is clean up those old snapshots. Every now and then we'll have someone call in and they've let their snapshots accumulate and accumulate. And the thing is, they get bigger with age. They continue, those differentials grow and grow and grow. And so we want to manage the snapshots and manage just their size so that they don't manage you. That would always be a good thing. And remember that snapshots are local. There's a common misconception that you can't, I'm sorry, I went to the wrong one, that you can't move or export snapshots. Or I'm sorry, stop, Jim. A common misconception is that maybe you want to move or export your snapshots. Well, actually, you do that through the replication process. We're not going to do that any other way. So that is snapshots and replication. And now we are going to look at your questions. Len, you want to kind of come up here and drive this and get us ready for our live Q&A.
So one thing about, I will say, on a serious point about snapshots is, unfortunately, we do get customers calling in, being hit with ransomware attacks. And, if you've got snapshots running, it really can save your day.
It does.
So it's happening more and more. Please run them. We can help you if any of yous do have that, and I hope not. We've got great people to help you run through that process of restoring from snapshots in a very tidy way and helping you very stressful time. Okay, we got live Q&A. We have no idea what the questions are.
None.
Using some tech, which I hope is going to work. Let's see.
Sweet.
Okay, we got the first one. So we're going to run through these. We've got about 6 minutes to go. Let's see. You want to get the first one, Pat?
Sure. What is the craziest support call you can share with us? As Len just indicated, we're seeing an unfortunate increase in ransomware. I think those are always the craziest support calls where they're like, it's all locked. What do we do? And we're like, well, let's open up a remote support connection and see where we go from there. Right. So that's what I would say are my craziest support calls in those situations. You have any crazy anecdotes you want to share?
Well, I did have one where a customer called in and they said, everything's gone. I said, what do you mean everything's gone? And it turns out that a disgruntled former employee had gotten access to the cluster, both the prod and DR, and started deleting VMs. And they were in a complete panic until they said, what's this Acronis appliance that I have here? And we were able to help them get connected with Acronis, get everything backed up. But that was the craziest one that I think I've ever dealt with.
That's a good one.
One thing I think, I'm going to move on to the second question.
Sure.
What does support intervention mean? I think everyone has probably seen this. Very simply, we have a sort of a engine that monitors things for anything that goes wrong, network cables being pulled in and out. If there's something that it can't self-resolve, and the cluster has this technology built in where it will resolve problems automatically, then you will get a support intervention message. Really what it's saying is give scale, tune in support. Doesn't mean anything terrible has happened, just means that we're seeing something that is happening. Give us a call. We can get connected in to see what's going on.
And that goes back to our point of call us, because that is the quickest way to get your help.
Absolutely. Okay, let's get the next one from Mike Ross. Okay, for a 3-node cluster, instead of adding the 4th node, can I add larger hard drives to say node 3 and then rebuild and resync node 3? Okay, so this is an interesting one. The answer to this one at the moment, no. Okay, so we can, when you're building a cluster, your first 3 nodes have to be the same size, but then your full 5th, 6th node and what have you, you can mix and match within some restrictions. So you can't mix and match networking. Certainly you can have a faster CPU, have more RAM. Can't unbalance the storage too much. So you can't say you have the 4th node with 200 terabytes, let's say, and nodes 1, 2, and 3 with only sort of 6 terabytes. So not at the moment, but I know it's a feature and something that is requested. And our product team would love to hear that sort of feedback.
Okay, I'll answer that second question there. Is data at rest encrypted on scale? Short answer, no, but there's a longer answer. Obviously, data at rest is something very doable in guest within HyperCore, but then also from the perspective of like a malicious actor pulls a drive from your system, what they really have is just a piece of a larger scribe array, and it would be extremely difficult to find any workable or retrievable data from that.
Yeah.
So I think you can rest assured, even though we don't have like a distinct encryption of data at rest, the odds of anything actually happening in terms of exfiltration from a cluster is very hard to do. That's what I would say. I don't know if either of you want to lend color to that.
Yeah, I mean, I think I think the way I look at this is if someone's in your data center and they're pulling out hard drives, you've probably got bigger problems than your data being encrypted, sort of thing. But yeah, the data is spread and actually.
Mm-hmm.
Yep, that's a good point there. Yeah, and that's where encryption, with third-party products, absolutely keep data safe. And so yeah,
for sure.
The one thing that I will say, and it's sort of misconception sometimes with our storage, is that a VM running on node 1, the data for it is actually spread across all the disks in the cluster, not just on node 1. We break the data up into blocks, we mirror it across all the disks, it's written across all the disks as such. When you live migrate VMs, not moving any data, just moving the contents of RAM from one node to another. Okay.
I can take that next one from Hannah. What are some of the most common issues support sees, and how could I troubleshoot before reaching out to support? The two that come to mind for me, and I'll let these guys chime in a second, but oftentimes drive failures. And that's really where we start our tier ones. That's one of the kind of simpler processes of getting them, being able to diagnose what's going on, see what's happening. But drive failures are one. And then another one is oftentimes if there's perhaps a snapshot or a replication issue. And we see that not infrequently. And what we can often do to diagnose that is really look at what is our network doing, because oftentimes those issues will kind of start in the network, and that's why we're having issue. We can look at our storage capacity. We can make sure that we have plenty of capacity there and things are going well.
Really?
Yeah, actually, just to add to that about the networking side, we do not have any firewall blocking traffic coming out of our cluster. So when there are replication issues or anything like that, remote support tunnel issues, I hate to say it's always the firewall that's causing the problem. So we see this many, many times.
Yeah.
We've got some issues with known firewalls with intrusion detection and prevention.
Right. Yep.
Like Meraki is one of them, where it can sometimes block some of those flows. You might need to adjust. I think that's about it. We're almost at time now, so I want to just say Thank you very much for attending, coming. Hope you found this really useful.